Hey everyone, and welcome. Today, we're jumping into a really cool engineering story straight from the Zerodha Tech blog. This is our explainer on how one of India's biggest stockbrokers hit the scaling limits of a super popular tech stack and decided to build something wildly efficient to replace it. We're talking about their journey from the well-known ELK stack to a custom solution they nicknamed Lodge.
So we're going to follow the classic engineering story. First up, we'll dig into the problem, what exactly happened when they started to outgrow the ELK stack. Then we'll tag along on their journey to find a better way. After that, we'll meet their custom solution Lodge and really get into the nitty-gritty of its main parts, ClickHouse, Vector, and Metabase. And to wrap it all up, we'll cover the real-world, hard-won lessons they learned along the way. All right, let's set the scene. The year is 2020, and Zerodha's business is just exploding. We're talking more than 10x growth in traffic. Now, that's a fantastic problem to have, but it puts an absolutely massive strain on your tech. And the first system to start screaming for help was their logging setup, the LK stack. What worked just fine a couple of years earlier was now starting to seriously choke under the load.
And the issues weren't just one little thing. It was a whole collection of problems. During the busiest trading hours, logs were getting delayed, which is a huge problem. Their storage costs were going through the roof because Elasticsearch was inflating their log data by 3 to 4 times. And for the developers, they found the query language, Lucene or KQL, to be a real pain. It's powerful, sure, but it's not exactly easy to use. On top of all that, any kind of analysis over long periods was just painfully slow, and it required these really beefy, expensive servers just to keep the lights on.
So the team knew, right? Just throwing more money and more expensive servers at this wasn't going to work long term. It was a band-aid, not a cure. It was time to find a completely different approach, a new stack that could handle their massive growth without costing a fortune or being a nightmare to manage. So they put together a really clear checklist. Number 1, it had to be easy to operate. Logging is already complicated enough. Number 2, it had to be cost-effective, especially since they need to store logs for years. It obviously had to be scalable, and this last one is crucial. It needed a solid security model, role-based access control, or RBAC. That's just a way of making sure different teams can only see the logs they're actually supposed to see. You know, they gave a popular alternative, Grafana Loki, a fair shot. Not once, but twice. The first time, back in 2019, it was just too complicated to set up. They came back to it in 2021, and while it was simpler, the performance just wasn't there when they tested it with their own data. Queries were slow, they timed out, and it was missing that robust security control they needed, so it was back to the drawing board. And that's where their own solution comes in, Lodge. As they joke in the blog, the name was supposed to be pronounced Loggy, but everyone just calls it Lodge. And it's not one thing they built from scratch, but a clever combination of best-in-class open-source tools that were perfectly tailored for their specific needs. So how does this log thing actually work? Well, it's got 3 main parts working together. Think of it like a factory line. It starts with Vector, which is like the conveyor belt that collects and sorts all the raw materials, the logs. Then you have ClickHouse, which is the giant, super efficient warehouse where everything that's stored. And finally, there's Metabase, which is like the front office with a big dashboard where you can see and analyze everything that's in the warehouse. Okay, let's talk about the real heart of this new system, ClickHouse. Now, ClickHouse is a special kind of database called a column-oriented database. Here's a simple way to think about it. A normal database reads data like you'd read a book, one full row at a time. ClickHouse reads data vertically, one column at a time. Why does that matter? Because for log analysis, you're often searching huge amounts of data, but you only care about a few columns, like the timestamp and the message. This makes it ridiculously fast for this kind of work. All right, for the more experienced engineers watching, this is where it gets really interesting. This is a peek at their database schema. A couple of things are super smart here. See the low cardinality of string for the log level? This is a huge optimization. Since there are only a few log levels, like info, error, debug, ClickHouse stores them as numbers behind the scenes, which saves a ton of space. And then look at partition by. They're basically putting their data into monthly folders. So when you search, ClickHouse doesn't have to look through the whole filing cabinet, just the right folder. Super smart. And what was the result of all this clever engineering? Well, the numbers are just staggering. In their own words, the disk savings were phenomenal. A 20x reduction. Let that sink in. 20 times smaller. Let's see what that actually looks like. And here's the proof, side by side. For the same 65 million logs, Elasticsearch took up over 22 gigabytes of space. ClickHouse? Just over 1 gigabyte. That's not a typo. The average size of a single log entry went from 340 bytes down to just 17. This isn't just an improvement, it's a complete game changer for costs and performance. And of course, less storage and better performance means less money. A lot less money. The old ELK setup cost them $2.67 an hour. The new ClickHouse cluster, even with more servers, costs less than half of that. How? Because ClickHouse is so darn efficient that it can run on much smaller, much cheaper machines. Okay, so we've established that ClickHouse is an absolute beast for storage. But that's only one part of the story, right? How do you actually get all those logs into it? And how do your developers actually use the data? Well, that's where the other two parts of Lodge, Vector, and Metabase come into play. Vector is their log pipeline, and they use it in this really clever two-step architecture. First, a small agent runs on every single server collecting logs. But here's the trick. Instead of sending them straight to the database, it forwards them to a central aggregator cluster. That aggregator then gathers up all the logs from all the agents and inserts them into ClickHouse in big, efficient batches. This two-step process turns out to be a lifesaver, and we'll see exactly why in a bit. And one of Vector's superpowers is its own transformation language, called VRL. This code snippet here is a real example. With just a few lines of code like this, right at the source, they can grab a messy log, check it for errors, pull out the important bits, clean it up, and build a perfect structured log before it ever even touches the database. It's like having a data cleanup crew on every machine. And the final piece of the puzzle is Metabase. This is the user interface, how people actually see the data. The killer feature for Zerodha was its solid role-based access control, which was a must-have. But they're also super honest about what it's not good at. It wasn't built for log searching, so you don't get that live, real-time scrolling feed of logs that developers love, and finding logs around a specific event can be tricky. So to make life easier for their developers and get around some of Metabase's limitations, they built their own simple command line tool. It lets an engineer just pop open their terminal and fire off a quick query, like this one here that's counting error logs by the minute. It's a great little tool for quick checks without needing to log into a whole dashboard. All right, now for my favorite part of any good engineering story, the stuff that went wrong. Because let's be real, no system is perfect. Their journey with ClickHouse wasn't all smooth sailing, and sharing these struggles is how we all learn and get better. So remember how they were sorting their data into those monthly folders or partitions? Well, that was their first challenge. It worked great for apps that didn't generate a lot of logs, but for their busiest services, most queries were only for the last day or two. So for those, they switched to daily partitions. It's a balancing act. You have to tune your partitioning strategy to how your teams actually search for things. But this was the big one, the real showstopper. During their peak traffic times, their database just stopped accepting new logs. It effectively became read-only. For a logging system, that is pretty much a catastrophe. What was happening? Well, every tiny log message from every agent was creating a tiny new data file in ClickHouse, and the database was literally drowning trying to merge them all. And the fix? It was that brilliant two-step vector architecture we talked about earlier. That central aggregator was the key. Instead of a million tiny writes hitting the database at once, the aggregator would bundle them all up into big, efficient batches. This gave them complete control over the write pressure on the database and made the whole system stable and predictable, even during their busiest moments. Problem solved? Okay, so let's wrap this all up. What are the big lessons here? First, Elk is a great tool, but at massive scale, it can really start to hurt your wallet and your performance. Second, building a custom stack with the right tools like Vector and ClickHouse can lead to incredible savings. And for the senior engineers out there, the big takeaway is this. With ClickHouse, you have to get your partitioning and insert batching right. It's not optional, it's critical. And that's the story of Lodge. It really makes you think, doesn't it? It's a perfect case study in knowing when a tool that served you well just isn't the right tool anymore. So the question to ask yourself is, what's the tipping point for your systems? When does that standard off-the-shelf solution stop being good enough? Thanks for watching this explainer.